The global fruit market is entering a booming era, with revenues exceeding $1 trillion each year, far surpassing the processed meat industry, rivaling the entire global dairy sector, and quietly becoming one of the world's most powerful money-making engines. But behind that massive figure lies an even bigger question. How are millions of tons of fruit handled each year? And how does that vast agricultural machine truly operate? In today's video, join Agriculture Insight as we travel across fruit orchards on every continent, where technology controls the precise moment of harvest, automated transportation and sorting systems take over, and processing and cold storage lines transform delicate fruits into a stable food supply that nourishes the planet. Let's begin the journey in Hawaii, where a stable tropical climate year-round has turned the islands into the cradle of nearly 99% of the bananas grown in the United States. From around March to October, banana plantations enter their main harvest season. During this period, farmers must make decisions very early, when the bananas are still green, firm enough to withstand the long processing journey ahead, yet mature enough to fully develop their flavor at the final stage. Harvesting bananas is not simply cutting them down, but a carefully controlled operation. The trunk is cut about 60 to 80 centimeters above the ground so that the heavy bunch falls in a pre-calculated direction, avoiding impact damage. The moment the blade touches the trunk, thick white banana sap gushes out, dense and sticky like glue, easily clinging to skin and equipment. For that reason, every movement is performed slowly and precisely, preserving the shape and quality of each individual hand of bananas. If for many other fruits, harvesting nearly marks the completion of the job, for bananas, it is only the beginning. A single banana bunch can weigh up to 50 kilograms, roughly the weight of an adult, making transportation an even greater challenge than the cutting itself. The solution lies not in human strength, but in a smart agricultural innovation known as a cableway system. Thanks to this system, bananas are no longer carried on shoulders or loaded onto rudimentary carts. Workers simply hook each bunch onto a suspended rail, allowing them to glide through the plantation like a carefully controlled flow. After being safely harvested and transported, bananas enter the processing chain, where one of the most distinctive products is fried bananas. Only green bananas that meet strict standards, thick peel, firm flesh, high starch content, are selected. Too young and they taste bland, too ripe and they become soft and break apart. From that moment, the journey of transforming a humble fruit into a golden, crispy snack, loved around the world, officially begins. Before entering the processing line, bananas are not fed directly into machines, but are gently lowered into large washing tanks, a mandatory rebirth step. Here, clean water jets cover the entire surface of the fruit, washing away dirt, residual sap at the stem, and invisible impurities. In some modern facilities, the wash water is treated with low levels of ozone or chlorine, enough to eliminate up to 99% of microorganisms while remaining safe for food processing. After being thoroughly washed, the next step is to peel the bananas completely. Workers score the peel with a knife, then soak the bananas in cold water to remove the sap and loosen the skin. Next, the bananas are then sliced by high-speed machines into uniform 3mm pieces, ideal for crispy chips. The slices pass through a gentle wash to remove excess starch before frying. And now, the banana slices enter their transformation stage. When fried in a traditional pan, the cook must carefully control the heat, constantly turning the slices by hand to ensure even cooking, prevent scorching, and preserve their beautiful golden color. In industrial fryers, however, the slices are immersed in oil heated to 180 degrees Celsius, automatically agitated, and evenly cooked in just about 2 minutes under precise monitoring. After excess oil is drained, the golden crispy banana chips are transferred into a rotating stainless steel drum for seasoning. With precise dosing, the flavor coats each slice evenly, ensuring every chip is crunchy, beautifully golden, and aromatic, ready to delight the taste buds. Before moving to the automated packaging line, the fried bananas undergo a final quality inspection. An intelligent electronic weighing system measures each gram precisely, dividing them into packages with preset weights. The bags are then air-sealed, tightly sealed, and transferred to the carton packing section. Next stop, let's head to Mexico, the heart of the global avocado industry. From the vast growing regions across the highlands of Michoacán, the country supplies nearly 45% of the world's avocado production, with annual export value exceeding $3 billion. Global agriculture has advanced to the point where robots can drive themselves, harvest, and sort fruit with remarkable precision. Yet avocados remain a rare exception. When it comes to harvesting avocados, humans are still at the very center. Avocado pickers do not harvest by quantity, but by selection. Only fruits that have developed for 8 to 12 months are kept, when the skin is still glossy, the structure firm enough, and completely free of blemishes. To reach the tall canopies, they use long poles fitted with sharp cutting blades, combined with sturdy ladders to access the most difficult spots. Each avocado is carefully caught as it leaves the branch and placed into a basket worn on the chest to avoid impact. They are then neatly arranged beneath the trees, ready to begin the next stage of their journey with their skin fully intact. At the factory, thousands of freshly received avocados are immediately placed on automated conveyor belts, heading straight to the washing area. The process begins with high-pressure spray nozzles at 3 to 5 bar, spraying from multiple directions to remove dirt and impurities embedded deep on the surface. Immediately after, the avocados pass through a recirculating wash tank containing a food-grade solution, helping reduce microbial load and extend shelf life. Once thoroughly cleaned, each avocado glides beneath a computer vision system for rapid high-resolution inspection. In a fraction of a second, advanced sensors analyze color, size, symmetry, and surface defects. Only fruits that meet strict standards of ripeness, shape, and exterior quality are precisely identified, gently picked by robotic arms, and seamlessly transferred to the next stage of processing. From this point, the frozen avocado production process officially begins. The selected fruits are sorted and moved directly to the peeling and pitting area, where machinery pauses, giving way to skilled human hands. With just a few precise motions, the smooth avocado flesh is carefully separated and kept intact, ready for the freezing stage that follows. The diced avocado flesh is then transferred to a rapid freezing system at -4°C or lower. This process locks enzyme activity, slows oxidation, and preserves the fruit's natural color and texture, allowing for long-term storage without the need for chemical additives. Once the temperature is stabilized, the avocados are precisely portioned and packed into specialized bags. Vacuum technology removes up to 100% of oxygen, minimizing discoloration and flavor loss, allowing the product to remain stable for up to 12 months throughout storage and international transportation. Each year in late June, when the peaches begin to blush with soft shades of pink and gold and release their sweet fragrance into the warm air, farmers step into the orchards to begin the harvest, marking the start of a new season. Harvesting peaches is a gentle task that demands great skill. Pickers do not pull or break the fruit. Instead, they cradle each peach in their palm and give it a slight, careful twist so it separates naturally from the branch. Every peach is received softly in the hand, avoiding contact with fingernails to protect the thin, velvety skin. Even the smallest scratch can cause the fruit to deteriorate quickly. Farmers often wear canvas picking bags at their hips, allowing them to place the peaches in carefully without pressure or bruising. A qualified peach is one that is mature enough. The pit has hardened, the flesh remains firm, the the stem looks fresh, and the branch still sways gently after the fruit is removed. What makes this process special is that peaches are not harvested by quantity, but by the precise moment of ripeness. Too early, and they lack flavor; too late, and they become too soft. It is this human precision that creates a taste no machine can replace. After harvesting, all the peaches are gathered and transported to the factory for the next stage of processing. At the factory, the process begins with a crucial step: washing the peaches. Their fuzzy skin easily traps dirt, while the delicate surface can be scratched with excessive force. Instead of high-pressure sprays, the facility uses gentle swirling water combined with bubble tanks. Tiny air bubbles penetrate the fine fuzz, lifting away dust without scrubbing. The water is maintained at a neutral pH to preserve the fruit's natural color and structure. The peaches are then transferred to an automated sorting line, where only those meeting size and shape standards are selected. Immediately afterward, the peaches move on to an automated sorting line, where only those meeting standard size and shape requirements are retained, ensuring uniformity and precision in every stage that follows. After being thoroughly washed, the peaches are transferred directly onto the peeling conveyor line, where the next transformation begins. The movement is steady and carefully calibrated to prevent bruising, ensuring each fruit remains intact as it enters the processing stage. For larger peaches, the skin is automatically removed using specialized peeling machines designed to follow the fruit's natural contour. In just moments, the thin outer layer is cleanly stripped away, revealing smooth, golden flesh beneath. Once peeled, the peaches move to the pitting station, where workers remove the stones by hand with firm yet precise motions, keeping the flesh whole and minimizing waste. In more advanced facilities, the entire sequence, positioning, peeling, and pit removal, can be completed fully automatically in as little as 3 seconds per fruit. Guided by sensors and precision blades, the system transforms raw peaches into perfectly shaped, uniform halves or slices, ready for the next stage of processing with remarkable speed and consistency. After peeling and pitting, the peaches are cut into evenly sized pieces and sent through a second washing stage. This step not only cleans the surface, but also removes the cellular juices released during cutting, a factor that could cause the peach pieces to lose freshness and discolor up to 30% faster if not treated immediately. Next, each peach slice is gently placed into glass jars and immersed in a clear syrup made from purified water and sugar. This solution not only adds a mild sweetness, but also helps the peaches maintain their bright golden color, plump appearance, and stable texture throughout storage. After being filled with syrup, the jars are transferred into a sealed heating chamber. Here, the temperature is carefully controlled to sterilize the product, eliminate any remaining microorganisms, and lock in flavor, allowing the peaches to be safely preserved for an extended period. Once the heat treatment is complete, the jars are labeled, printed with expiration dates, and packed into cartons, ready to leave the factory for distribution to the market. When it comes to sheer abundance, the world is home to more than 30,000 species of seaweed, spanning environments from tropical coral reefs to ice-covered polar regions. Yet few people realize that seaweed's slimy texture is in fact its most unique biological armor. It acts both as a flexible, rope-like structure that allows seaweed to stretch and sway with violent waves, and as a moisture-locking membrane that prevents dehydration when tides recede. Although Asia accounts for 97% of global seaweed production, each country holds a very different strategic card. China dominates industrial-scale seaweed processing, supplying thickening agents for the additives market, materials that quietly provide smoothness to lipstick, toothpaste, and processed foods. South Korea and Japan, by contrast, are masters of value elevation. They transform seaweed into the soul of sushi and kimbap, driving the price of each dried sheet to dozens of times higher than its raw form. At the opposite end of the spectrum, Indonesia and Northern Europe are pioneering seaweed as a strategic ecological weapon. This power lies in seaweed's whole-body absorption ability. Every surface can absorb nutrients, rather than relying on roots like terrestrial plants. As a result, in regions with dense seaweed growth, excess fertilizer residues and heavy metals in the water can drop dramatically after just a single growth cycle, directly eliminating the causes of oxygen depletion that suffocate fish and shrimp. And now, we arrive at the process everyone has been waiting for. Each year, more than 30,000 tons of dried seaweed are exported from South Korea through high-tech production lines, generating over $700 million in revenue, surpassing even the export value of fresh pears and many other major fruit commodities. In South Korea, the peak of the green gold harvest typically begins in November, when seawater temperatures drop below 12 degrees Celsius, the ideal threshold for seaweed to reach maximum thickness and nutrient density. However, the operation only truly scales up once the blades reach 15 to 20 centimeters in length. This is the golden size that allows mechanical harvesting systems to precisely trim the upper portion without damaging the root structure, ensuring that every 15 days a new crop is ready to regenerate. Specialized vessels equipped with drum harvesters over 1 meter in diameter head offshore. These massive rotating drums function like giant wheels, rolling along cultivation lines and lifting dozens of meters of biomass out of the water at once. Here, high-speed circular cutting blades, spinning at thousands of revolutions per minute, sweep across the nets like an industrial clipper, shaving only the upper fronds while leaving exactly 5 centimeters of the base firmly anchored to the substrate. The entire process is powered by a fully hydraulic system. The moment the seaweed leaves the cutting blades, high-capacity suction hoses pull the cascading biomass directly into pre-washed tanks. Immediately afterward, mechanical compression systems squeeze out excess water before the seaweed is packed into specialized mesh bags weighing up to 800 kilograms each. Finally, onboard cranes hoist these massive bags onto barges for overnight transport back to shore. This closed-loop operation allows tens of tons of seaweed to be processed within just a few hours, locking in biological freshness before the first light of dawn. If net-based cultivation forms the backbone of Asia's seaweed industry, then on the other side of the globe, the North Atlantic relies on a very different resource: vast, natural kelp forests, anchored to rocky coastal seabeds, where biomass density can reach 20-30 kilograms of fresh seaweed per square meter during peak season. During the harvesting season, small to mid-sized fishing vessels approach mature kelp beds near shore. Crews haul massive kelp fronds directly onto the deck by hand or with low-power mechanical winches, then selectively cut approximately 60 to 70% of the blade length, leaving the holdfast and basal stem firmly attached to the seabed. With this method, kelp forests can regenerate almost completely within just 3 to 5 months, depending on water conditions and light availability. On deck, the seaweed is cleaned and roughly sorted, then bundled and transported back to shore the same day. This steady flow of raw material supplies dietary supplements, animal feed, and organic fertilizers, where biological renewability is valued more highly than short-term yield. Unlike industrialized models, this harvesting approach treats seaweed as a living component of the marine ecosystem, extracting just enough to allow the ocean time to recover, rather than pushing it to exhaustion. At the opposite end of the spectrum lies a far more meticulous approach. Hand harvesting remains the gold standard in regions with rugged coastlines or within strictly protected marine areas, such as Brittany or Connemara. Only during extreme low tide can harvesters access the exposed rock shelves, where they carefully cut individual blades of kelp or dulse using scissors or small knives. What defines this method is absolute selectivity. Only seaweed leaves meeting the highest standards of cleanliness and bioactive compound concentration are taken, It is this painstaking precision that elevates the harvest into a premium raw material, reserved exclusively for luxury cosmetics and high-grade pharmaceutical extracts, sectors where cellular purity is valued far above sheer volume. But harvesting is only the first half of the journey. In South Korea, the true value of seaweed is only unlocked once it enters a closed-loop processing transformation, where every variable, from moisture levels to cellular structure, is tightly controlled. The journey of a single gim sheet is, in essence, a race against time. The moment the seaweed leaves the ocean, the raw material must be processed immediately to lock in freshness and suppress enzymes that would otherwise degrade quality. Inside the factory, the cleaning process takes place in massive intake tanks, where water temperatures are kept below 10 Celsius to prevent the onset of decomposition. Instead of using high-pressure water jets that could damage the delicate blades, the system relies on vertical axis agitators to generate slow, controlled vortex flows, preserving the integrity of the seaweed's fibrous structure. At the same time, millions of fine air bubbles released from the bottom of the tanks seep into every fold of the leaves, gently dislodging sand, sediment, and attached organisms, impurities that often hide within microscopic crevices, using buoyant force and the natural circulation of rising air. After cleaning, the seaweed is fed into high-speed cutting machines, where it is shredded into fine strands measuring 2 to 5 millimeters in length. This size is a deliberate technical calculation, small enough to ensure even dispersion, yet structurally intact enough to allow the fibers to interlock. The entire operation is carried out in a fully closed system, maximizing nutrient retention while preventing oxidation from ambient air. The mixture then moves immediately into slow agitation conditioning tanks for 20 to 40 minutes, where the seaweed is rehydrated and its polysaccharides are released. Gentle paddles maintain a continuous, low shear flow, producing a stable suspension with consistent viscosity. As a result, the seaweed fibers remain evenly distributed and ready for sheet forming without clumping. At this stage, the seaweed's first recognizable form officially emerges through a critical shaping process. The seaweed is blended with water at a precisely calibrated ratio, after which metered pumping systems spread the mixture onto moving mesh molds. Low-pressure spray nozzles, programmed with exacting precision, distribute the slurry so that every square centimeter of the mesh receives the same amount of material. This is the moment when a gim sheet takes on its initial structure, demanding extreme uniformity to prevent rippling or warping once moisture is removed. Next, the seaweed enters a multi-stage drying chamber, a long tunnel system divided into strictly controlled temperature zones ranging from 40 to 60 degrees Celsius. Rather than using high heat for rapid dehydration, the factory relies on high-capacity recirculating warm airflow to draw out moisture gradually. Controlled drying process is the key to locking in the seaweed's signature ocean aroma and preserving its deep, glossy blue-black color, while also protecting heat-sensitive vitamins, such as vitamins A and C, from degradation. At this stage, the sheets are not yet released for consumption. Instead, they are stacked, aligned, and bundled into temporary batches. These bundles of dried seaweed are sealed in moisture-resistant packaging, allowing for short-term storage and internal transport, without altering the sheet's color or their inherent biological crispness. The gim then moves directly into a fully automated, precision seasoning line. The sheets travel along a low-speed roller conveyor, ensuring uniform surface exposure to a network of low-pressure micro-spray nozzles. Here, a thin layer of refined vegetable oil, most commonly sesame oil or neutral vegetable oils, is applied with tightly controlled dosing at 1.5 grams of oil per 100 grams of dried seaweed. In parallel, fine salt and signature seasoning blends such as mustard, wasabi, or proprietary formulations are evenly dispersed, keeping flavor variation between sheets below 5%. After seasoning, the gim enters a second roasting chamber, where exposure time is shorter, approximately 30 seconds, while the temperature is precisely calibrated at around 180 degrees Celsius. The purpose of this final roast is to lock in seasoning aromas, evaporate excess oil, and create a uniformly dry, crisp surface, the defining factor behind the clean, audible snap that characterizes premium-grade gim. Once the gim reaches a fully dry, crisp state and is evenly infused with seasoning, the automated packaging line is activated. Robotic pick-and-place arms, operating at speeds of over 100 units per minute, swiftly transfer each stack of sheets into plastic containers according to pre-programmed portion specifications. Before the process is completed, a specialized desiccant packet is placed at the base of each container. The package is then sealed with a heat-bonded film using infrared sealing technology, completely isolating the contents from ambient moisture and preserving the product's signature crispness with absolute consistency. Now, let's step into the kitchen, where one of the most iconic dishes made from seaweed comes to life: sushi. On the work surface, a layer of still-warm rice is spread evenly over a sheet of dried nori, which is maintained at 7 to 8% moisture content before use. The filling is placed neatly at the center, and everything is hand-rolled with controlled pressure, just enough for the seaweed to wrap tightly around the rice without breaking its structure. The nori begins to absorb moisture from the rice, shifting from crisp to pliable and locking the filling firmly inside. At this moment, the seaweed releases a subtle ocean aroma and deep umami notes, blending with the softness of the rice and the natural sweetness of the fish. Beyond sushi, another iconic dish made from seaweed is seaweed soup. The cooking process begins by soaking dried seaweed in cool water to rehydrate it, allowing the strands to expand and regain their natural structure. After being rinsed and trimmed, the seaweed is briefly sautéed with sesame oil, then simmered with water or broth at a moderate temperature for a short period. During cooking, the seaweed releases essential minerals and bioactive compounds directly into the soup, including iodine, calcium, iron, and soluble polysaccharides. Because the soup is not cooked for long, many heat-sensitive micronutrients are preserved. As a result, seaweed soup is considered a nutrient-dense yet light dish, commonly consumed to replenish minerals, support metabolic balance, and aid recovery in everyday meals. If you look at the bell pepper market straightforwardly, the picture is quite clear. China grows the most in the world. Mexico is the major supplier for the United States, and Spain functions as the key distribution hub for all of Europe. These three regions link together to form a massive flow of trade, and it's this connection that underpins a bell pepper market worth nearly $10 billion. In supermarkets, many people assume red peppers are the premium choice because they take longer to ripen and therefore cost more. But from a cooking perspective, each color has its own purpose. Green peppers are crisp with a light sharpness, great for stir-fry and Asian dishes. Red peppers are sweeter and softer, ideal for salads and grilling. And yellow or orange peppers sit somewhere in the middle, easy to use across many types of dishes. So the question isn't which color is superior, it's which one fits the dish you're making. And the idea that light can change a pepper's color, that's completely true. In greenhouses, growers can speed up or slow down the color-changing process simply by adjusting the type or intensity of lighting. It's a very common technique in modern agriculture, but one that most people would never notice just by looking at a multicolored pepper in the supermarket. The most critical factor determining the quality of bell peppers is the timing of harvest. Within just 7 to 14 days, they can shift from green to red or yellow. Pick them too early and they lack flavor and color. Leave them just a few days too long and their crispness and market value drop noticeably. In other words, harvesting bell peppers is genuinely a race against time. Early autumn is when the peppers reach their fullest shape and strongest coloring. And it's also when the season officially begins. Across fields spanning dozens of hectares, specialized harvesters start up simultaneously, producing the signature hum of modern agriculture. They move slowly but steadily, sliding harvesting arms into each plant, lifting the entire stem, and shaking it so the peppers fall onto the conveyor belt. From there, the stream of peppers passes through rotating brushes, suction fans, and continuous sorting systems that remove leaves, soil, and defective fruit, leaving only the high-quality peppers to drop neatly into the collection bins. Thanks to these machines, productivity has changed completely. A single harvester can replace hundreds of workers, and what once took a month to gather can now be collected in just a few days. At many large farms, weekly harvest volumes can exceed 300 tons, a figure nearly impossible to achieve with manual labor alone. This isn't just a story about faster harvesting. It's a clear example of how technology is reshaping agriculture. Fewer people, less time, and far more output, all while keeping product quality consistent. When grown in open fields, bell peppers can only be harvested during a few warm and dry months. But to sustain an industry that consumes millions of tons each year, growers have to extend the production season. The solution lies in greenhouses, where light, temperature, and humidity are controlled down to the smallest detail, allowing peppers to be harvested year-round. In this environment, the harvesting process also changes. Workers don't pull or shake the plants as they would outdoors. Instead, they use pruning shears to cut each pepper individually to keep the stem intact, because even a slight bruise on the stem can lower the fruit's grade during sorting. The freshly cut peppers are placed on plastic trays mounted on small electric carts, vehicles that can run continuously between rows barely 80 centimeters wide without breaking branches or scratching the fruit. Once the trays are full, the carts unload the peppers into a small trailer hitched to a tractor. Its low chassis allows quick loading, its tight turning wheels help it maneuver easily in confined spaces, and safety sensors reduce collisions, crucial because even a small scratch can make a pepper deteriorate 30 to 40% faster. When an entire greenhouse block is finished, a line of carts heads straight to the processing area, where facilities can receive anywhere from tens to over 200 tons of fresh peppers per day, depending on the size of the farm. This is the key link that keeps the bell pepper supply stable throughout the year, regardless of weather or season. As soon as the peppers reach the collection point, massive hydraulic machines immediately lift the crates into the processing line. With a single tilt, an entire crate of bell peppers pours onto the conveyor like a waterfall. But instead of bruising, cushioned chutes and soft conveyor belts absorb the impact, keeping every pepper intact. Thanks to a precisely timed speed control system, up to 2,000 crates can be handled smoothly each day, an impressive starting point for the industrial journey of bell peppers. The first step in the industrial process is cleaning. Crates of bell peppers move into an automated washing system, rolling across massive horizontal brushes that strip away layers of soil as if they were never there. Immediately after, they meet a blast of high-pressure water combined with strong airflow, washing and drying the peppers in just a fraction of a second. After cleaning, bell peppers move into the most critical stage of the entire production line, sorting, where the commercial fate of each pepper is decided. On the system of rubber-coated rollers, the peppers rotate, not just to move forward, but to expose every part of their surface, including areas that are usually hidden, such as the bottom, the stem, and the grooves between the lobes. Above them, a multi-angle camera system captures 60 to 120 images per pepper, combined with high-precision 3D sensors and color sensors. Together, they record the pepper's size, shape, color uniformity, surface gloss, physiological ripeness, and any surface damage as small as 0.2 millimeters. Right after the scanning zone, each pepper enters an individual tray, a structure specifically designed for difficult produce like bell peppers, which have irregular shapes and thin, easily scratched skins. Each tray holds exactly one pepper, equipped with an ultra-sensitive scale with an accuracy margin under ±1 gram, along with an auxiliary rotation mechanism to complete any missing angles of data before the system makes its grading decision. In practice, if a sorting line can accurately grade bell peppers, it can handle almost any other challenging fruit or vegetable. No two bell peppers look alike. Their lobes are uneven, their shapes asymmetrical, and their value depends heavily on the perfection of their surface. This is why the market has more machines dedicated specifically to bell peppers than to apples, tomatoes, or mangoes, even though those crops sometimes have much higher overall production volumes. On the market, most bell peppers are sold whole in plastic bags. In the United States alone, the number exceeds 5 billion fresh peppers every year, meaning billions of those familiar bags you see on store shelves. But few people realize this isn't just a convenient packaging method, it's also a vivid demonstration of consumer psychology at work. Red and yellow peppers trigger appetite, while green suggests freshness. When all three colors sit next to one another, they create an irresistible visual pull, a mix of contrast and harmony that distracts you, makes you hesitate, and ultimately makes you far more likely to add to cart than you planned. However, plastic bags are only used for retail. At industrial scale, where demand is measured in tons rather than in bags, bell peppers are packed into cardboard cartons. Each box weighs 5 to 10 kilograms and holds 30 to 80 peppers, meeting the standards required for storage and long-distance transport. From there, fleets of refrigerated trucks line up and leave the processing plant, carrying bell peppers to supermarkets, wholesale markets, and even high-end restaurants across the country. Kiwi is one of the most iconic brand twists in global agriculture. Although closely associated with New Zealand, this fruit actually originates from China, where it once grew wild and was known as the Chinese gooseberry. The turning point came in 1904, when a New Zealand school principal brought the first seeds home. There, the fruit was renamed after the kiwi bird, a name strong enough to carry it out of the Asian mountains and onto the world's fruit map. Today, China remains the largest kiwi producer, accounting for more than 50% of global output, while New Zealand contributes only around 7%. Yet through clever rebranding, strict quality standards, and mastery of cold chain logistics, New Zealand dominates the premium export market, turning a Chinese fruit into a symbol of value and quality. Few people know that there are over 50 kiwi species, most of which are inedible or yield small, sour, and hard-to-store fruit. The global market, therefore, revolves around just two main varieties: green kiwi, with its classic sweet tart flavor, and gold kiwi, prized for its rich sweetness and premium image. These two have defined the modern kiwi industry. Interestingly, kiwi is also one of the most nutrient-dense fruits on Earth. It contains nearly twice as much vitamin C as oranges, along with serotonin and antioxidants that naturally improve sleep, a kind of healthy sleeping aid born from nature itself. To create such achievements, we must swim against the current, back to the very origin of the kiwi, where the story doesn't begin with ripe fruit, but with a cultivation system engineered to perfection in every detail. The life of a kiwi begins with its trellis system, the most crucial foundation of the entire orchard. Before planting, Farmers erect concrete or wooden posts about 1.8 to 2 meters high, connected by tensioned steel wires to form a horizontal framework above the ground. Since kiwi plants are climbers, their entire growth depends on how well they can cling to and spread across this structure. After about 200 days, young kiwi vines start to seek support on their own, winding gently around the posts as they climb upward to maintain balance. When the canopy closes over the trellis, the kiwi orchard enters the most delicate stage of the entire season: flowering and pollination. Male and female blossoms grow on separate plants, and each flower stays open for only about 4 days. To avoid leaving pollination to chance, large farms combine natural bees with mechanical pollination devices, machines equipped with upward-facing nozzles that blow fine clouds of pollen across the vines. Pollination robots move along the rows, releasing pollen collected from male plants precisely onto each blooming female flower. This method ensures the pollen reaches the stigma accurately, compensating for cool, damp days when bees are less active. In those brief moments, the future of the entire kiwi harvest is almost decided, before the petals close and the young fruit begin to form. Similarly, the irrigation and fertilization systems for kiwi follow the same upward spray principle. Because the vines have dense canopies and tall trellises, all equipment is designed to deliver water, nutrients, or micronutrient solutions as a fine mist rising from below, spreading evenly across the undersides of the leaves and around the root zone. High-pressure sprayers generate powerful airflows that drive the droplets deep into the canopy, reducing waste while enhancing absorption efficiency. Every year, from around March to June, kiwi orchards enter the most critical stage of the entire growing season. It is a brief but intense period when the fruit is not harvested at full ripeness, but instead cut from the vines while still firm, at the precise biological point that allows it to be stored and transported over long distances. To determine the exact harvest time, kiwi growers don't rely on color or softness. Instead, they measure dry matter content and Brix level inside the fruit. When the dry matter exceeds about 15% and the Brix level reaches approximately 6.5, harvesting can begin. The rare balance point where the fruit can continue ripening after picking while remaining stable for extended cold storage. For premium varieties like Zespri Sungold, this process still depends almost entirely on human hands. Farmers physically assess each fruit's weight, firmness, and condition before every cut, because harvesting even a few days too early or too late can sharply reduce the crop's value. However, as production scales up, fully manual harvesting creates an enormous demand for labor within a very short window. As a result, mechanization is gradually being introduced to support large-scale orchards. Whether harvested by hand or by machine, kiwi fruit are immediately collected in large specialized bins right in the orchard. From there, they are loaded onto trailers and transported out of the farm as quickly as possible, heading straight to central packing facilities and cold storage warehouses, where the next stages of grading, preservation, and processing take place. From the very first stage of intake, kiwi bins are opened gradually according to a pre-calculated rhythm, allowing the fruit to flow out in a controlled stream rather than tumble out all at once. As they move onto the tiered conveyor system, each kiwi rolls gently across a layer of soft rubber, spreading into a single, evenly spaced line that ensures a smooth flow and minimizes impact. This deliberate slowing down by design throughout the process helps factories reduce kiwi damage by more than 7% each year, saving hundreds of thousands of dollars in losses. Along this steady flow, clusters of soft, flexible fibers lightly brush the surface of each fruit, removing residual soil while rotating them at different angles to expose every side. At the end of the line, workers stand along the conveyor for an initial quality check. They don't just remove scratched or misshapen fruit, but also detect subtle signs machines might miss, such as abnormal softness, newly formed abrasions, or early symptoms of skin disease. In practice, each shift can intercept hundreds of substandard kiwi fruit right here before they move deeper into later processing stages. After being cleaned and stabilized in flow, the kiwi fruit enter an automated machine vision sorting system, where both speed and precision reach their peak. Each fruit is guided into a separate channel, evenly spaced to avoid overlapping during movement. Above the conveyor, clusters of high-speed cameras capture images from multiple angles under tightly controlled lighting, accurately recording each kiwi's shape, size, and even the tiniest surface imperfections. In less than 30 seconds, the image data of each fruit is analyzed, compared, and classified. Immediately afterward, the mechanical sorting system directs every kiwi into the correct lane, from premium-grade fruit for the fresh market to those destined for processing. With a standard configuration, the line can handle over 10,000 kiwi fruit per hour, while maintaining an almost perfect level of consistency. After sorting, the kiwi fruit move on to the packaging and labeling stage. On the automated line, each fruit is placed into a molded tray that holds it securely in place, preventing rolling and collision. Label rolls rotate continuously, releasing pre-printed traceability stickers that are precisely applied to the surface of each kiwi by synchronized robotic arms moving in rhythm with the conveyor. At the same time, the automatic tray packing system arranges the kiwi fruit into padded cartons, maintaining even spacing between each fruit. With a standard configuration, a single line can process over 20,000 kiwi fruit per shift, ensuring every piece is properly secured, accurately labeled, and fully prepared for cold storage and onward transportation. Inside the quality control lab, each batch of kiwi fruit is analyzed right after packing. Technicians cut samples and measure flesh firmness using a pressure tester. Values between 4.5 and 6.5 kg/F indicate the fruit has reached the ideal technical maturity for storage and continued ripening. At the same time, a Brix meter determines soluble sugar content, while moisture and dry matter levels are checked to assess freshness and shelf life. All data are entered into a traceability system, creating an electronic profile for every batch. Thanks to this process, only kiwi fruit meeting strict standards of structure, sweetness, and biological ripeness are cleared for the next stage, cold storage. When trays of fresh kiwi fruit leave the cold storage, traveling thousands of kilometers in atmosphere-controlled containers to reach global markets, another part of the harvest, the fruit that falls short of export standards, quietly takes a different path. These kiwis enter the pressing line, where they begin a new life cycle in a different form, as pure kiwi juice. To make juice, kiwi fruit can't go straight into the press. They must first pass through a crucial step, peeling. The machines used for this stage typically handle about 500 fruits per hour, fast enough to keep pace with the production line, yet gentle enough not to crush the delicate flesh. Immediately afterward, the kiwi fruit are chopped into pieces and fed into an industrial grinder. Here, the fruit's cellular structure is carefully broken down, creating a thick puree that releases the maximum amount of juice within. Finally, the filtered kiwi juice is precisely filled into sterilized bottles under controlled conditions, with a volume deviation of less than 2%. As the bottles leave the production line, each one carries the result of precision, consistent quality, and an optimized shelf life, born from accuracy at every preceding stage. Beyond its familiar role in juice, kiwi enjoys a far richer life in the world of cuisine. With its gentle tartness, signature green hue, and smooth texture, it becomes an ideal ingredient for desserts, from mousses and tarts to the delicate topping layers of cakes. Just a few thin slices of kiwi can create a striking visual accent, bringing freshness and vibrancy to any dessert plate. But kiwi's versatility extends well beyond sweets. It is also used in salads, grilled meat pairings, and fine dining presentations, prized for its natural ability to balance richness and cleanse the palate. A small fruit with an unexpectedly sophisticated touch.